Okay, we will talk about the DHCP. And from this part, the layer 2 main technology we all finish, like the VLAN, like STP, link aggregation, and the VSU. And of course, about layer 2, we also have lots of other technologies. But about this training, we finish. And later, we will begin to talk about the layer 3 technology and also some technology consider about the terminals, like the DHCP, like the VRRP. And why we use DHCP? Because about this training, the first day, the first topic, we talk about the IP address, right? Every devices about the terminal and also some network devices and some others. And all the devices we have to the basic parameter we have to know is the IP address, includes the IP detail IP address and the mask. And of these devices is a gateway, is a terminal. We also have to tell the gateway and maybe some DNS parameters, something like this. So how to assign the IP address for the terminal? We have two types. One is static. Static means one by one to let the terminal give the IP address manually, okay? And another one is use the DHCP, Dynamic Host Configuration Protocol. And we can use this protocol to allocate the IP address from the DHCP server. And about the terminal, don't need to configure the IP address again. Only need to enable the DHCP function, and then the terminal devices will ask the server, please please give me an IP address, and we will send out the message and then to give a reply, and also get the gateway address, DNS address, and something like this. So this is a function of DHCP. And after taking this course, I hope you can familiar which scenario we will use the DHCP is better. And then the working principle of the DHCP and what different types we will use if we deploy the DHCP. And the second, we will to know how to give the key configuration of the DHCP and a special application for the relay. And the last part, we will talk something about the DHCP snooping. This technology also is very useful in our network to protect our network security. Okay, so this is the purpose we have to know after finish this part. And the first one, let's say, is the working principle. Why we need the DHCP? Because our laptop, maybe our computer, maybe our phone, or maybe some smarter applications, all the devices we have to use the IP address, right? Maybe now in your network, not only IPv4 address is used, but also some scenario we will use IPv6 address. But the first step, we need an address. So how to give the IP address and how to manage the IP address, how to get the IP address efficiently and more securely and without no perceived user experience. So this is the requirement we want to meet. And we say we have two types to get an IP address. The first one is static IP address allocation. For example, now this is my Windows 11. And if you want to get an IP to visit the internet, you can select manually to get a static IP address. So in this topology, you have to give the IP address, give the subnet mask, give the gateway, and also the DNS. And when you do the configuration of the static, there's some problem. For example, because I have some knowledge of the network, so I know what's the meaning of 192.168.101. But a lot of users don't know. I even don't know why I need this word. If I give the wrong parameter, what's the result? So if you use a static way, The first one, every user have to know what's the meaning of the IP address and then give the correct information of the address. So even if all users know how to manually configure the IP address, there are also another problem. The first one, the engineer of the maintenance center staff have to develop an IP allocation table, right? And you have to record which IP address already used for which terminals and which address now is free, something like this. But in the real network, one person maybe not only one IP address. I have the laptop. I also have my computer on the room. I also have a phone. Maybe in the future I will have an iPad. So you have to record lots of information. And another one, users are likely to have IP address conflict due to the misconfiguration setting, right? If you told the customer you must give the address to become 192.168.101, otherwise you cannot visit the internet. But when you do the configuration, maybe you add the wrong number, but you don't know it. Give the IP address of 10.1. So there maybe is a conflict in your network. So we hope is there a way to reduce the difficulty for users to configure IP addresses, right? If we use a DHCP for customer, for the user, only need to click to choose the edit IP setting to become DHCP and save is enough. The customer doesn't need to know what's the meaning of 192.168.1.1. Why we don't give the address information like 255, 255. You only click DHCP is enough. And the second, we hope we can reduce the workload of the network center maintenance staff. The engineer doesn't need to maintain the table. I can directly in some places to check the allocation of IP address. So this is the second. The third one, we also hope some technology can avoid the IP address conflict due to the misconfiguration, right? If the IP address allocation from the machine, not for people. Machine, this is smart. I can remember which IP address already been used. So in this requirement, we will use a technology we call is DHCP. So DHCP has lots of advantage. And the name of DHCP is Dynamic Host Configuration Protocol. And this is used as IFC for 2131 and use a CS architecture. C is client, S is server. So when we deploy the DHCP in our network, we have two rules. One is client, another one for server. And what's the definition of this part? I will explain later. And if we use the DHCP in our network, the server is responsible for centralized management. I can know everything, which IP address is being used now and how long time. And if someone wants to ask a new IP address, which IP address can be used. So everything will be managed on the server. And the client only need to submit a configuration request to the server, and then the server can give the reply and allocate the IP address information. And pay attention about this part. How to get an IP address or how to let you know which IP address can be used. We will use a DHCP message. That means between the client and the server, I will send some message to you and you give me some message. And in this message, I can get the information I want to know. And this message we call is DHCP message. And the DHCP message are encapsulated with the UDP protocol. UDP is the protocol of transport layer. And the port number of server is listened to 67, and the port number for the client is 68. So pay attention about this port number because maybe in your network, you do some ACL. You do some access list controller to help your network, but pay attention to allow the port number 67 and 68. Otherwise, the DHCP message cannot be forwarded in the devices. So finally, the client maybe also cannot get the IP address. So this is the first part we have to know, the port number. And if you deploy the DHCP in the network, this is a typical topology. The client maybe connect with a switch and then to connect with another switch. And about the right switch, maybe is a layer 3 switch, maybe is a router, or maybe is a special server. Okay, special server. And the PC will ask a question, what is my IP address? Then the DHCP protocol will send the message out and to ask the server, please help me to forward an IP address for this PC. So this is a function. And about the DHCP system components, we have 3 rules. First one we call is client. It's easy for us to understand, right? Client means a host that needs to be obtain an IP address dynamically. About the host, maybe it's your laptop, maybe it's your personal computer, maybe it's your phone, maybe it's your iPad. Okay, and someone needs an IP address and send out the request from the devices. These devices we call is client. Also, maybe your network devices also can be the DHCP client, but you have to enable the DHCP client function. And then when I ask the IP address, who can help me to assign IP address? Who can manage the IP address? These devices we call is DHCP server. And the DHCP server can be a network, also can be a server, but these devices need to have the ability to provide the IP address. This is responsible to assign IP address to client and also have to manage these IP addresses. What's the mean manager? For example, I have to record what's the time I assign IP address for the client. Or maybe I will give the special time, and after the time, I have to take the IP address, to let the client to use another one or not. I have to record this information, and I also have to know which IP address also can be used for the other devices. So this is the managers of the IP address. And pay attention. Between client and server, we say they will send the DHCP message and then to get the information, right? But the DHCP message by default is broadcast message. So the client and the server have to in the same LAN, the same broadcast domain, for example, same VLAN. That means maybe in your network, one VLAN, one DHCP server. It's impossible, right? Maybe you will have lots of departments and different IP segments and located in different VLAN. It's impossible. So if in your network you have several departments and in different broadcast domain, but you only have one DHCP server, you have to deploy the third rule we call it DHCP relay. So the relay is used in the network that DHCP client and the DHCP server are not in the same subnet. Okay, in this scenario, we have to deploy the DHCP relay. So how to make the devices to become relay or to become server or to become client? Also, we have to add the configuration. Then the devices will become this rule. So these are 3 types of components. And let's see the detail of the DHCP process. The first one, if the client and the server in the same network. So first, if the DHCP client need an IP address, what mean need an IP address? If I'm a user, I use a Windows system, and I select how to get the MAC IP address. I choose DHCP and save the configuration. Then the client will directly send out the DHCP discovery message. This is a broadcast message, and the function of the message is, can someone allocate me an IP address or not? This is the broadcast message. Because the DHCP server is located in the same network with the client, so the server will give a reply. Because the DHCP server will already give the configuration, and this is the ability of the server. So the server will give the reply. The reply message is DHCP offer. And this also is a broadcast message. And in the message, it will show you I can allocate IP address and the IP address 192.168.102/24 to you. Of course, maybe also have the information like gateway and DNS. But here I only let the sentence to let you know what's the function of this DHCP message. And the next step, the client will send out the request message. Okay, I will use this message you allocate for me. Then the server will give a reply. Okay, I acknowledge it because I have to write down to this this information. For example, this IP address for which MAC address, and one I assign IP address for the information, something like this. So the DHCP server will give the acknowledgement. This is the main process. And about the discovery message, this is the first request message from the PC is a broadcast. So I use a Wireshark to get the details of discovery. How to get the message is broadcast or not? You have to check the layer 2 destination MAC address or F, right? And also the destination IP address or 255. Because this discovery message is the first broadcast message from PC. PC doesn't know where is the server. So all the destination MAC address and the destination IP address will be broadcast. And the type of discovery, here we can see lots of information. Like the message type is 1 and the Ethernet 0, hardware length is 6. Something like this. And we only see the detail of the destination part and the message type is enough. Okay, and on the option 55, we can see lots of information like I need subnet mask, I need the router information, DNS server information, and the time information, something like this. This is a DHCP discovery message. And then the server will give a reply, right? And the DHCP offer message is the first message returned by the DHCP server. If in our network we deploy lots of servers, more than one, the PC will keep the DHCP offer received first. Who sent me the first message of the offer? I will use this IP address information. So this also is a problem. Why maybe someone deploys an illegal DHCP server in your network? There's a mistake. So this is a principle. And we also can see the offer information. The destination MAC address will be unicast, right? This destination MAC address is the MAC address of the PC, and the source MAC address is the MAC address of the server. And this is the offer information. Okay, and I will tell you what's your subnet mask and the renewal time value and the rebounding time value and IP address list time, something like this. So this is a DHCP offer. And later, the client will send the request message from the PC, and the message sent to your server will show you, okay, I want to use this IP address. So this also will be the broadcast message, okay? But the type will become the request. And I will use this information, IP address, which IP address I will use, 192.168, something like this. And then the server will give a reply. Give a reply means I will tell you which IP address already been used, and I have the IP address pool. I also will record it. So this is a process of the packet exchange. And after getting an IP address, another process is IP rejection and release. For example, the decline, the IP address 192.168.12 you provide is already being used and I refuse to use it. After the server gives acknowledgement to me, I will send out a free ARP. The function is to detect the IP address is conflict or not. If I send out the IP address, for example, I ask the IP address of 192.168.1.2, what's your MAC address? If someone give me a reply, that means in this network, someone already used the IP address. So in this scenario, I will send out the DHCP decline to tell the server the IP address is conflict. Please give me a new one. So this one we call is DHCP decline. And another one is DHCP release. I don't want to use the address you allocate. Please give it to someone else. For example, now I'm offline. I turn off my computer and I never use the IP address again. So in this time, I will send the release message to the DHCP server, and the server can assign the IP address for another client. So this way we can improve the efficiency of the IP address. And another one is DHCP list renewal. Up on 50 time, or maybe up on 87.5% time, we will send out the list term to the server. For example, I would like to continue use the IP address you allocate to me. Is that okay? Then the server will give a reply, okay. The client will send the request message to the server. Okay. For example, first time maybe you assign the IP address to me only 24 hours. And half time means I use 12 hours later, I will send a message to you. Please let me continue to use the IP address. I can make the time longer. Maybe in this time, the message maybe will discard because of the network problem. Sometimes the packets will be discarded. So up on the 87.5% time, I will send the message again if I don't receive the acknowledgement from the server. I would like to continue use the IP address you allocate. Is that okay? Then I will give you, if you can continue use the message is DHCP ACK. If not, you cannot use it. I will use a DHCP NAK to you. If 2 times I send the request to server, but don't get any reply until the time is up, the IP address will be released from the server and assign maybe a new IP address for you. So pay attention about this part. Of course, about the list renewal action, the client will do it automatically. We don't need to give any configuration. So here's lots of message we use on the DHCP, but lots of the message is the broadcast message. So about your client and your server, you have to within the same client, especially when you do the configuration of the VLAN. If they in different VLAN, we have to add the DHCP relay. Maybe a little difficult when you deploy the configuration on the WLAN because of your client connect with AP connect with AC, but AP and AC may be located in the layer 3 network. So in this scenario, we have some special configuration to do. Say a DHCP protocols message and what's the usage of the DHCP and what's the application. And here is the basic configuration here. The configuration also is very important for us to understand. So maybe have a break time now, 15 minutes later. Let's come back to see the detail of the configuration. It's okay for you? 15 minutes later, let's come back. Now let's continue about the configuration. First one, we have to enable the DHCP server. This part configuration belongs to the DHCP server. About the client, it's very easy. You only need to open the button, to click the button to use the DHCP get IP address is enough. Yet about the server, first you have to enable the function of the DHCP server. In the global, and the command is service DHCP. And then you have to create the IP address pool. And in this pool, you can assign which IP address can be allocated for the client. And the name, for example, you can use VLAN1 or maybe the other name like IT, something else. And then we have to use this command, network and the IP address and the mask. And this IP address and this mask, the totally range will finally define the IP address which part can be used. And here we give 256 IP address used for customer, right? And the default router configuration is a gateway address, because if the client want to wait the different segment, one is the IP address and the mask, and the second one is the gateway. Okay, and the next step, you also can have to tell them what's the DNS server address, because the DNS server address is used to translate the URL name, the domain name, to become an IP address. So this server must allocate in your network and can provide this function. And the gateway and the DNS server is optional configuration. That means you maybe if you don't add these two commands, the function of DHCP server also can work, but your client, maybe the information is not enough, so finally cannot reach the internet. And also we can configure the least expiry date of dynamic allocate IP address. I remember is 1 hour, 0 minutes, 0 seconds. No, it's 1 day. It's 1 day, sorry. That means about this IP address, you can use 24 hours. So this is a DHCP server basic configuration. And here is an example. For your client, you only to select use a DHCP to get an IP address. Use a DHCP to get a DNS server. And about the server, you have to enable the function and to create support. The range is 192.60.1.0, and here is a mask. And the default router is 192.72.16.1.224. And this IP address now is a gateway, right? And this IP address will never assign will never allocate for the client. And the DNS server, you can add more than one address, like 114.114.114 and 8.8.8.8, two IP address. And the list time is 080. Okay, so this is the basic configuration. And after we finish the configuration, we can use this configuration to check. Show IP address list information and what's the IP DHCP pool, and maybe in your network some IP address is conflict, so you have to do the troubleshooting. And you also can say which address now is allocated for the client. Like this this example, show IP DHCP bounding, and now you can say 3 clients already get an IP address. One is 1.1, 1.200, and 2.1, and what's a MAC address and the list time. The first is the day, and then the hours and the minutes. And we also have different type. Pay attention about this one. If we use those commands to let the client get an IP address, the type is automatically. But about the DHCP, we also can choose the way is manually. we can let one IP address is fixed for the special server. For example, your FTP server also need an IP address to wait some special resources. And in this scenario, you can directly allocate the special IP address 1.200 only used for your FTP server. So it also can work. And the manually way means this IP address can be used all the time until you use the command to delete the configuration. So DHCP also can be used for different scenario. And when you delete the IP address, the manually IP address, this IP address also can be allocated by the other client. So this is the application. And the DHCP relay means the client and the server located in different network. So we need the relay devices to receive the broadcast message from the client and to convert the broadcast message to become the unicast and send to the server. And then the server will give a reply. The relay have to make the unicast message to become broadcast again. In this scenario, the client and the server can be in different network, maybe different IP segment, maybe different VLAN, it doesn't matter. But you have to use the command to let the devices to become DHCP relay. And the key command is, of course, you have to enable DHCP relay agent. The command is same with DHCP server, service DHCP. You only add this command on the devices, then I receive the message from the client. I can de-encapsulate the message and recognize the detail and then to convert to become unicast message and to the next step. So you have to enable the server DHCP. And the key command is different one, is the second one. Add a global DHCP server address. Because about the relay, we have to make the broadcast message to become unicast message, right? Unicast message means you have the special destination IP address. So you have to let the relay know who is your DHCP server. And the command is IP helper address, and this is the IP address of the server. Of course, this IP address must be the real address of the DHCP server. And then you can configure the normal IP address, one interface to connect with the client part, and another interface to connect with the server side. Of course, about these two configuration, maybe this devices is not the DHCP relay, you also have to add this configuration. But the special one is the second one. You have to let the devices know who is your DHCP server. And later, these devices will become the DHCP relay and receive the DHCP discovery message from the client. I will direct it to make to become the unicast. The destination MAC address will be destination IP address will become 172.2.2.1. So this is the configuration of the relay. Okay, so this is the basic one for the DHCP. Actually, for the command, it's very easy to understand, right? And the two key points. One is by default, the DHCP message is a broadcast message. So you have to let the client and the server in the same network, in the same broadcast domain. Otherwise, you have to add the DHCP relay and to let the relay devices know who is your DHCP server. Of course, we have to add the key command. So this is the DHCP basic. And the question about this part? It's easy for you to understand? It's easy, right? If no more question, maybe we will continue next part of the DHCP security. Because in our network, maybe there is a rogue DHCP server, an illegal DHCP server. What's mean illegal DHCP server? For example, I am an attacker and I deploy a DHCP server in your network, and I also create the pool. I also give you the gateway address, but this IP address and the gateway will let you to force a message to my site. Or maybe I give you the IP address and the gateway, but not have the routing information in your network. So finally, you will find your client can get an IP address, but cannot visit the internet, or maybe visit some resources. So this is the function of the illegal DHCP server. And let's see the process why the PC1 cannot know this is an illegal DHCP server. Let's see the process. PC1 first will send out the discover message, right? This is the broadcast message. When the switch receives this message, according to the micro address forwarding principle, I will broadcast the message. So the message will be sent out to the call switch DHCP server, the correct DHCP server. Also will be blood to the illegal DHCP server, right? And then these two DHCP server will give a reply of the offer message to the access switch. But about the access switch, I also will blood the broadcast message because the offer message also the offer message is a unicast message. So this message will be sent to PC1. But pay attention about PC1. Maybe I will receive the offer message from the illegal DHCP server at first. And according to the principle, if PC1 receives multiple offer message, I will choose the fast one, the first one. Okay, so finally, I will receive the information from the illegal DHCP server. And the second one, I will discard it. I will choose this one. So later I will send the requestment, and this request message will be sent to the DHCP server, and the DHCP server will give the acknowledgement to tell you, okay, now you can use an IP address. But finally, I get an IP address, but I cannot go to the internet. I can't go on the internet. So this is the process why we finally get an IP address, but I cannot visit the internet. So how to solve this problem? We can deploy the DHCP snooping in our network. The main part of this process is, first one, the PC1 doesn't know I guess the information is correct or not, right? The second one, because when the access switch receives a message from the PC1 discovery, and the switch directly broadcast to everyone, includes the normal DHCP server, also includes the illegal DHCP server. And then when receives the offer message from this two DHCP server, then the switch also directly forwards the message to the PC, and then the PC will not know which information is correct, which information is not incorrect. So we can deploy the DHCP snooping to let the access switch know which part message should be correct, which part is incorrect. So if we enable the DHCP on the access switch, and then two type of ports will be added into the switch. One is untrust port, and another one is trust port. So if we enable the DHCP snooping function on the switch, all the interface will become untrust port. And we can make one interface to become trust. This interface should be connected with the correct DHCP server. And the rest of the interface will become untrust port. So in this scenario, when the access switch receives the offer message again, I only forward the traffic from the trusted interface. All the other information from the untrusted interface I will directly discard. So this is a function if we enable the snowping on the access switch. So in this scenario, the PC only will receive the correct offer message. And finally, I will get the correct information from the normal DHCP server. So this is the first function of the DHCP snowping. And the second one not only have the trust and untrust port, but also the switch will build a table to record the correct MAC address information. When we forward the message, I only will forward the information. We have the same MAC address. Let's see the process. For example, also the same topology. And about the switch, we call switch at first, we give the correct configuration of DHCP, right? Create the port and give the gateway and give the DNS, something like this. And then next step, this is a key configuration on the switch on the DHCP server. And then access switch will enable the snowping function, so all the interface will become untrusted port by default. Then we can make the gigabit 24 connect with the call switch, connect with the DHCP server to become the trust port. Here is the configuration. First, we have to enable IP DHCP snowping at first, and then all the interface will become untrusted by default. Then we can enter the interface gigabit 0/24 to make IP DHCP snowping trust. Sorry. To make it IP DHCP snowping trust. Then the interface of the 24 will become the trusted interface. After we add the configuration, what's the step? Both the DHCP offer and ACK message from the DHCP server received from the untrusted interface will be discarded. So in this scenario, if when the PC1 send out the discover message to the access switch also will be flagged to correct server and to incorrect server. But when we give the reply of the offer, I only forward from the trust interface, and this message will be discarded. So this is a function of the trust interface. And the second one, not only about the trust and untrusted interface, the switch also will bounding a special DHCP snowping entry. Snowping of the DHCP ACK message received by the trust interface. From this interface, we will receive the correct message, right, from the DHCP server. And in the ACK message, we can know the IP address information. We also can get some MAC address information according to the encapsulation. And this is the ACK message. We can know which IP address will be assigned for the client. The IP address is 12.0.0.101. And the client MAC address, I also know it. And what's the IP release time? This information will be added into the access switch snowping table. Okay, the IP address, MAC address, and the list time. And also the port number and the VLAN. This port number and the VLAN information from the MAC address table. Then when we in the switch use the command show IP DHCP snowping bounding, you can see this information, right? And what's the next step? The DHCP snowping and table can be deleted in this way. If you enable the DHCP snowping, I will learn this message automatically. Once I receive the ACK from the DHCP server, I will record this information into the table. And this message only can be deleted. The first one, the least time expires. Successfully renewal will not be deleted because half time or maybe 87.5% time I will ask the server if I want to use the IP address again, right? We will refresh the type. Or maybe the snooping on legion times release or decline message sent by the client. That means the client will send this message to the DHCP server. I don't want to use this IP address again. And the access switch also will delete this entry. Or maybe an NAK message is received from the trust port. That means the DHCP server will decide this IP address cannot be used for the client. When a user active deletes the binding record using the command clear IP DHCP snooping bounding, then this entry also will be deleted. That's all. If we enable DHCP snooping on the switch can recognize every DHCP packet. The switch will know each bit what's the meaning of the DHCP packets, and I can record so many information from the packets. Otherwise, the access switch will think this is a broadcast message, this is a unicast message I directly send out. So this is a main function of the DHCP snooping. And when I forward the traffic, I also will consider this message should be forwarded out or not. Not only consider about the MAC address table, but we also have to consider about the snooping bounding table. So this is a maintenance. And how to check the message can be forwarded out or not? We will check the layer 2 source MAC address and the client MAC address together. If they are same, we will continue to forward it. Otherwise, we will directly discuss the request message. Request message is used from the client, right? Should be the client. Yes. The source MAC address and the client MAC address is same. Then I will forward the request message to continue to forward. Otherwise, this message will be directly discarded. Yes, Wireshark is very useful because you can see every bit here and you can see the meaning. You can realize the principle better. When you do the practice, and you can use a Wireshark to get every package and analyze it. This is the snooping. And another feature like DHCP snooping, non-relay DHCP message. If there is a relay devices in the network, the following configuration should be done in the global mode. Otherwise, the relay maybe have some problem. IP DHCP snooping track gate. So this is the non-relay DHCP message. Because about the default, the DHCP snooping on the access switch or maybe the other switch only can recognize some normal message like the request, like the discovery, something like this. But if in your network you deploy the relay, right? Relay will make the broadcast message to become unicast message. So if you want to the snooping successfully, you also have to let the switch know this is special message from the relay. So you have to add this configuration. Okay. And the port on DHCP snooping in fact can be a wired switch port, a layer 2 AP port, or layer 2 encapsulate server interface. All the interface can be used into the DHCP snooping. Okay. And pay attention, this is a limitation. DHCP snooping and DHCP relay are not support for simultaneously deployment in the VRF scenarios. Maybe if you deploy some MPLS technology in your network, you will see the VRF, or maybe you use a BGP, you can see the VRF message, VRF technology. But here you only know the limitation is enough. And another one also is very important is DHCP snowping loss forwarding. We say if you enable the DHCP snowping in your switch will build a DHCP snowping table, right? When you forward the message, I will track the table. The source MAC address and the client MAC address should be same or not. If the information is same, I will continue forward. Otherwise, I will discard. But pay attention. The entry also has a number limit. For example, we only allowed 500 entries in the snowping table. Then, if here more than 500 clients, that means your entry is full. So if you enable this function of loss forwarding, the rest of message, maybe the message from 501 client, I will direct it to forward the message out. Although this information not located on the table because the table is full. I also can forward the message out. Otherwise, if you don't enable this function, I will discard. I only forward the message located on the entry. So this function we call is DHCP snowping loss forwarding. Okay, and the configuration is here. IP DHCP snowping loss forward. Okay, that's all about the principle and some key command. And here some questions. Let's say together. The terminal obtains the IP address through DHCP, and the server finally determines in which message is information such as IP address mask provided to the terminal included. This question will ask the message from the server. Okay, which answer should be correct? Anyone can give me the answer? DHCP ACK? D? It should be B. Offer. Actually, in your offer message, we already give you the detail. Which IP address you can use, what's a mask, what's a gateway. But acknowledgement means I agree you can use this message. And I will record the information in the pool. It's clear for you? Let's come back to see the offer. Right here, you can see the offer contains the IP address, the gateway, the DNS parameters, and other configuration here. That means the first time I reply to you, you can get all the information. So you only to tell me you want to use or not is enough. But the function of the DNS of the ACK is I will give you a reply. Okay, now I will record it and to write down the information, then the address pool, this IP address cannot be used for other guys. So the detailed information already located in the offer. So now it's clear for you? It's okay for you, right? And then let's see the next question. The DHCP snowpin feature creates DHCP snowpin binding table entries. By which message? What's the answer here? This one should be discover, offer, request, or ACK. Can you give me some answer? This message will be from the ACK. When we receive the ACK, yes, correct answer. When we will receive the message from the ACK to the server and add this information into the binding table to record the MAC address information and some list time and something like this. And then we will for the traffic not only consider about the MAC address table, but we also have to check the snowpin binding tables. So this is the second one. And about the third one, an access switch that has deployed DHCP snowpin and also maintains the binding table. Under what circumstance will the binding entries will be deleted? Which scenario we will delete the entries of the binding table? This is a multi-choice. Can you show me some answer? Nobody is too difficult for you? D. Yeah, D is the one scenario that we directly use the command to delete the entry manually. And another question should be A, B, C, and D, right? We already explain it when we talk about here. There are four scenarios, and the first three scenarios, the entry will be deleted automatically, and we also can use a command to delete manually. So the last answer is A, B, C, D. Yes. So, any question? So about this traffic, we talk about the basic principle of DHCP, right? How to work off the server and what's the DHCP packet between the client and the server, and which scenario we will need the DHCP relay, and what's the key configuration of these devices. And the second one of the DHCP security, we focus on the DHCP snowpin. Of course, security we also have the other scenario and another technology, but we not talk about here. And about the DHCP snowpin, if we enable this function on the switch, pay attention. This function is enabled on the switch. not about the client, not about the server. On the switch, if we enable this function, and then the interface will become untrusted interface. And you can make the legal DHCP server the interface to become trust. And the access switch will force the traffic according to some special information to check the source MAC address and check the client MAC address. Finally, we will build a DHCP bounding table, right? And then if you want to delete the entry, we have 3 automatic scenario, and you also can use a command to delete. Okay, so that's all about the DHCP part. DHCP, I think, is very useful, especially if you deploy the WLAN scenario in your network. Your client, maybe is a phone, your station will get the IP address from the DHCP, not about the manually. Maybe in your office, in the wired network, someone will use a static IP address, but in your wireless network, I think lots of people will use DHCP to get an IP address. So this one is very useful.